Alright, so today we're going to be talking about graphing systems of equations. But before we do that, we need to know what a system of equations is. So a system of equations is basically just several different equations that are all going to be graphed on the same coordinate plane. So for instance, you could have y equals 34.2 minus 14.9x. You could have another equation, y equals 3.3 plus 4.7x. Notice they're both linear equations because they both have two variables to the first power. Um, and these are a system if we graph them on the same coordinate plane. Since they don't have the same slope, if you look at their slope values, they are going to cross at some point. And where these equations where they cross is considered a solution. So let's talk about the three possibilities of different lines. These particular lines do end up crossing if you graph them out. But let's say we have two lines with the same slope. In this case, they're parallel and they're never going to cross. So in this case, there is no solution. You could also have the case where when you graph the line, and they end up being right on top of each other. In this case, every solution you put into one line is also going to be true for the other line. This is multiple lines graphed on top of each other. So in this case, you have an infinite number of solutions. So infinitely many solutions. And the main type we're going to talk about is if we have just two lines crossing at a single point. We have one solution, and that looks like this, where you just have one solution for your two lines that are crossing. In this case, the graph is called consistent. If they don't cross, it's called inconsistent. This one, another term we can use for this is independent. If the lines cross everywhere, that would mean they're consistent and just dependent. But since these just cross at one point, they're consistent and independent. So let's just get into some examples here. So we have these two equations here, y equals negative x plus 5, and we have y equals x minus 3. We want to know what the solution to those graphs are. If we put them on a coordinate plane here, this is probably where you want to be very careful about how you draw your lines. You're most likely going to want to use graph paper when doing this. But we know the first one has a y-intercept of 5, and it has a slope of negative 1. So we're going to go down 1 over 1. Should look something like this. You can already tell my line's not drawn very nicely. The other one, we have a y-intercept of negative 3 and a slope of 1. So we're going to go up 1 over 1, up 1 over 1. So it's going to look something like this. And you can see they cross at this point here, which on my graph without graph paper, it's a little hard to tell. But if you were to graph this um, on graph paper, you should be able to tell what that point is. But let's just, what the question is asking is if this has one solution, no solution, or infinitely many solutions. You can tell by just looking at the graph that there is only one solution here. Another example for that is y equals negative x plus 5 and 2x plus 2y equals negative 8. We'll go ahead and take a look at what they look like. Again, negative x plus 5 is going to have a y-intercept at 5. It's going to have a slope of negative 1. So down 1, over 1, something like that. 2x plus 2y equals negative 8. I'm going to save time and just figure out the x and y intercepts to graph this one. So if I put 0 in for x, I end up getting y equals negative 4. So I know I have a point at 0, negative 4. And if I put 0 in for y, the same thing happens. I get 2x equals negative 8. I get x equals negative 4. So I know if y is 0, then x is negative 4. It has something like that. Now it looks to me like those two have a similar slope, that they're parallel. This would mean that there are no solutions because they never cross. So finally, let's look at if we do actually want to find the solution to that. And I'm going to actually see if I can bring up a graph paper here. Open this, paint. Bring this over. Alright. So let's say I have the equation here, system of equations of y equals negative x plus 8, and I also have y equals 4x minus 7. So again, in this case, we'll graph these. You see y equals mx plus b, so I have a y-intercept at 8. We'll make this line red. So y-intercept at 8. 1, 2, 3, 4, 5, 6, 7, 8. I also have a slope of negative 1, so we're going to go down 1 over 1. Down 1 over 1. So my line is going to go through these 3 points. Let's see if I can edit that. Something like that. Alright. My other equation is y equals 4x minus 7. I graph this one in red, so I'll graph the other one in blue. So I have a y-intercept in this case. My b is negative 7, so 1, 2, 3, 4, 5, 6, 7. And I have a slope of 4, so I'm going to go up 4 over 1. And let's put a line through those points. It's a little off there. Move this down. Move this. Something about like that. So my lines are a little off here. They're supposed to cross at 3, 5. If we go 1, 2, 3, 1, 2, 3, 4, 5. My lines aren't quite good enough. But if you use a ruler, I'm obviously doing this on the computer, so it's a little tough to graph those straight lines. But you should see an intersection of 1, 2, 3, 1. Should be about here somewhere. If I make my dot thick enough, it's accurate. But hopefully when you use a ruler on graph paper, you'll be able to tell where those two lines meet at their point. Let's just try one more. Maybe I can get it more accurate this time. Let's open this in Paint. Put it over. Alright, this time we have an equation of x plus 2y equals 5. And we have an equation of 2x plus 4y equals 2. I'm just going to go ahead and graph these using intercept since they're not in slope-intercept form. We'll just take my x-intercept would be where y is 0. So x plus 0 equals 5. So I get a point at x equals 5 where y is 0. Right there. The other one is if x is 0, what does y equal? Well, y is going to equal 5 halves or 2.5. So we'll put a point at 2.5. And let's make a line through these. Something like that. Right, the other equation I have here, I'll do the same thing. So if I have x is 0, sorry for the blue equation, if x is 0, then 4y equals 2, so y is 1/2 where x is 0. We also know that where y is 0, 2x equals 2, so x is 1. So where y is 0, x is 1. So it's going to look something like this. Going through those 2 points, it looks like let's see if I graph these correctly. Looks like I'm going to end up with some parallel lines. Since these lines are parallel, what that means is that there's no solution. So if they don't cross, remember, there's no solution. If they do cross at a point, that coordinate where they cross is your final answer.